All right, so this is what an atom kind of looks like. The majority of the atom is empty space. That's pretty much the big thing that you need to know. In the middle of the atom is your nucleus, which is positively charged, and then you got your electrons flying around the nucleus. Okay, so the atom is made out of 3 subatomic particles. The first are called protons. They have a positive charge, and the number of protons tells you which element that atom is. All right, so on your way in, you should have picked up a periodic table, and if you guys take a look at the boxes on the periodic table, you can figure out the number of protons each element has by looking at the number on the top of the box. So for example, let's take a look at just the first one. Hydrogen. Hydrogen has 1 proton. Lithium has 3 protons. Beryllium has 4 protons. Okay, that's pretty much what the protons tell you. It tells you what element that atom is. Okay, so if I ask you, hey, there's an atom with 11 protons, then you would say that it is sodium. Okay. Any questions on the protons? Okay. A lot of this should probably be review, right? All right, let's go to the next one. The next one is, they're called neutrons, and neutrons have no charge. And the number of neutrons tells you which isotope the atom is going to be. Okay, and we'll talk a little bit more detail about isotopes. Okay, but neutrons tell you which isotope that atom is. Okay, an easy way to think about isotopes is they're all the same element, but they're like different versions of the same element. Okay, so for example, I guess an analogy in real life would be you have like regular Coke, right? And then you have things like Coke Zero, you have Cherry Coke, right? They're all Coke, but they're different versions of the same thing. Same thing with isotopes. For example, if we have something like carbon, carbon is the element, but there are different isotopes such as carbon-10, carbon-11, carbon-12, so on and so forth. The names aren't that interesting. They're just the element, dash, and then a number, but the neutrons tell you what isotope it's going to be. That's what isotopes are. They're different versions of the same element. Okay, and we'll go more into detail about isotopes in just a bit. All right, and then the last subatomic particle are called electrons, and they have a negative charge, and they tell you the atomic charge. Okay, so you guys probably learned this in your previous chem class, but basically it's going to tell you if an atom is going to have a charge of like +1, -2, +3, so on and so forth. Okay, that's going to depend on the number of electrons. Okay, so this unit is going to focus mostly on how different numbers of each subatomic particle is going to affect what the atom is going to be, what the isotope is, what the charge is, so on and so forth. So the next thing we're going to look at is going to be how to write different versions of the atomic symbol. Okay, so let's start with carbon right here as our example. You guys probably know how to find the symbol for carbon, right? Just look at the periodic table, it's the capital letter. So this C right here is a symbol of the element. Now, on the AP test, they add different versions of these symbols to kind of see if you guys understand the different types of information given to you. So on the top left of this number, top left of the symbol, this number right here is called the mass number. And an easy way to think about the mass number is just going to be the number of protons plus the number of neutrons. Okay, so on the top left is where we denote the mass number. And the mass number is basically how many protons and how many neutrons are inside of that atom. Okay. And then on the bottom right is going to be the atomic number. Okay, and the atomic number is just the number of protons. It's just the number on top of the box on the periodic table. So carbon has a 6, so we put a 6 on the bottom left. Okay, so just quick check to see if you guys understand. Carbon has 6 protons, right? The mass number is protons plus neutrons. So if you have this atom right here, how many neutrons does this atom have? 6, correct. This is going to have 6 neutrons. And easy way to check it is carbon always has 6 protons. So 6 protons plus 6 neutrons gives you 12 as the mass number. So that's how you find mass number. So this is an isotope of carbon, and the isotope, the way that you would write the name is carbon 12-12. And carbon 12 has 6 protons, 6 neutrons. All right, so that's one way of denoting an isotope. A lot of times you'll actually see this symbol without the bottom left. So oftentimes you'll see it as just the 12 on the top left and then C. It means the exact same thing. A lot of people don't write the 6 because it's carbon, it's always going to be 6 on the bottom left. All right, so that's how you write isotopes. Any questions about that? Pretty easy so far? AP Chem is light, right? All right, guys, so I have the answers up, or most of the answers up there. So if you're still working, please feel free to finish and you can check your answers. But let me start going over the process. So 2.1, Hg mercury is 80 protons. For that, you just look at the periodic table. The number on top of the box is 80. So that's how you get the protons. For the neutrons, we can see that the mass number is 197. So you just do 197 minus 80. Should give you 117 neutrons. Everybody good with that? Okay. I didn't talk about electrons, so sorry about that, but some of you guys might have known from your previous chem class. The charge of the element, so whether it's positive or negative, goes on the top right. There's nothing on the top right. If there's nothing on the top right, that means it is neutral, exactly, which means you have the same number of protons and electrons. So it's going to be 80 electrons. So I didn't mention that, but if you guys remembered it, great job. If not, now you know. So that's going to be 2.1. Any questions on that one? All right, 2.2, we're going to write down the neutral atom that has 92 protons and 143. Well, if you look on the periodic table, 92 is uranium, or U, so that's how we get this information. And then for the mass number, we just add up the protons and the neutron. 92 plus 143 is 235. So the first notation we can write is uranium-235. The other one that we learned is the top left and the bottom left, 235 on the top and 92 on the bottom, and then you can also omit the 92. So that's the 3 different ways that we can write the name of an isotope. Okay, so we're going to move on now. We're going to be talking about atomic weight now. So, excuse me, we talked about the number on the top, which is the atomic number, or the protons. We got the symbol that's in the middle. Now this number at the bottom is going to be called the atomic weight. A lot of times it's also referred to as the molar mass. We'll talk more about that next unit, and you guys might have learned it that way, but these two terms are pretty interchangeable. Okay, so atomic weight, molar mass is referring to atomic weight. It's just the number on the bottom of the box. Okay, so this number on the bottom is kind of interesting because it doesn't actually tell you what every single atom weighs. Because let's think about it this way, okay? If you have an isotope, right, 2 different isotopes. So let's say that we have potassium 39 and potassium 40, okay? And you guys don't need to write this down. This is just me kind of explaining why we have this number. If you guys take a look at these two, potassium 39 has 19 protons and 40 also has 19 protons as well, right? The difference is that 39 is going to have 20 neutrons and 40 is going to have 21 neutrons. Okay, so far so good? Make sense? Okay. Now, if you just think about it logically, which one do you think, I know these are really small things, but which one do you think will weigh more, 39 or 40? 40 obviously is going to weigh more because it has an extra neutron, right? So that's the reason why, if you guys take a look at the atomic weight on the periodic table, you have these decimals. It's because different isotopes have different weights, but when we're actually doing real chemistry, we can't look at every single atom that's involved in that reaction, right? Different atoms will have different weights depending on the isotopes. So this number right here is actually going to be an average, okay? And specifically, it's the average based on their relative abundances, okay? So you just kind of need to write average and then relative abundance if you want to make a note of that. What that means is these very smart nerds, they studied chemistry, right? And they found the ratios of each element in nature. So when we look at potassium, they see the ratio of 39, the ratio of 40, all these different isotopes, and they found the average, and that's how we get this number right here. So when we're doing chemistry, we can use this average because when you take a sample of that element, they're pretty much going to average out to this value right here. Okay, and so one of the questions the AP test really likes to ask is they like to ask about these, these relative abundances, basically these ratios. Okay, and I'm going to show you guys how to solve that right now. So we're going to jump straight into 2.3 together, and then I'll have you guys try 2.4 on your own. All right, so 2.3 tells us that in nature, chlorine is 75.78% chlorine 35 and about 24.22% chlorine 37. And they want you to find the atomic weight of chlorine. Okay, so this is just kind of basic algebra, but I know it's been a long summer, so we're going to go over how to solve this. The first thing that you want to do is you want to take your percentage right here and turn it into a decimal. Okay, the way you turn a percentage into a decimal is you move the decimal. You can divide by 100. Yeah, divide by 100, or just simply move the decimal twice to the left. So 75.78 is going to become 0.7578. Okay? And let me redraw that arrow. And then what you're going to do is you're going to take the mass number of chlorine 35, which is 35, and you're just going to multiply these two values together. So we're just going to multiply them. So let's just put them in brackets like that. Okay, and then you're going to do the same thing with chlorine 37. So let me give you like 30 seconds to do that. Just convert this into this format right here, just to see if you understand how to convert that. Okay, so 24.22 becomes 0.2422, and then your 37 is obviously 37. Okay, so far so good? All right, so the way that we calculate the atomic weight or the average weight is you pretty much just solve these two values, and then you add them up, and that's going to give you your atomic weight of chlorine. Okay, it's just pretty basic algebra from there. So I'll give you about 30 seconds to solve that out. You can check with the person next to you, just to make sure you guys got the same answer. I'll also talk about a little bit about formatting, but see if you can solve it. And if you finish early, you can start on 2.4. All right, guys, so I got the answers on the board. If you want to check your answers, if you're still solving 2.4, totally fine. Please feel free to finish up and you can check your answers. Yeah, if you need one. Yeah. Alrighty, guys. Any questions as you guys are finishing up? Hopefully not too bad yet. Alright, so let me go over a couple things as we're finishing up these problems. A lot of times, a question that I get from people is how many numbers after the decimal point should I add? You guys might have done sig figs in the past, or you guys might see things about significant figures on your textbook and stuff. But I'll be honest with you guys, don't need to worry too much about them. My recommendation is try to give, if you have them, obviously, 3 to 4 numbers after the decimal point, and that should be fine. I've had people get 5s on the AP test doing that. I personally did that as well when I took the AP Chem test, and it turned out fine. Okay, so 3 to 4 numbers are usually safe when you guys do these. So I know there's a lot of rules about sig figs. People stress out about them. You don't need to remember them. Okay, just 3 to 4 numbers after the decimal point, and you should be good. Please don't add all of them. More is not always better. So if you write like 15 numbers after the decimal point, the grader will probably get annoyed and mark it down. So 3 to 4 numbers should be good. Okay, that's different from moles, correct? All right, everybody good so far? Okay. All right, so we are going to move on now, and we're going to be talking about something you guys probably have not learned yet.
Broken calculator. Useless.
Broken?
I mean, batteries, but I doubt you're ever going to put any. Got a good one. Hopefully, people chew on these.
I don't got food right now. Do you want to go out and get something?
Or cash it, Mr.
Yeah. I'll go around though. Yeah, because he gets like picky with it. Okay, so selenium has 34 protons. Hopefully you guys saw that on the periodic table. The most abundant one is selenium 80. So all you got to do is 80 minus 34, and that'll give you 46. So the most abundant one has 46 neutrons. All right. So that's pretty much all the different variations of the mass spectra you're going to get. Sometimes they'll ask you to draw one, but actually, I think we're going to go over that in a second. But any questions on 2.5 and 2.6?
No.
Okay. All right, one thing I do want to mention, and this might come up on your test, and by might, I mean it will. So you guys want to write this down. But a key thing about the mass spectra is that the number of electrons does not affect the mass spectra. Okay? That's a key thing to know. The number of electrons does not affect the mass spectra. And the reason why is electrons are so much smaller than protons and neutrons that even if you have more or less, it's not going to affect the actual weight of the atom very much, to the point where the mass spectra can pick it up. So, for example, in our pillar right here, selenium 80, okay, you might have selenium, and this is just an example, you might have selenium 2+ in there, you might have selenium -1 in there, you might have selenium 4+ in there, so on and so forth. Okay, you might have different ions in there, but you're gonna have the same mass numbers, the same isotopes. Okay, so keep that in mind. Electrons do not affect the mass spectra. This is only based on the protons and the electrons. Okay, last thing we're going to do before we go on our break is we're going to go over how to draw a mass spectra. And it's very, very easy. We're just going to do one problem just for the sake of time. Let me zoom in a little. We're going to skip 2.7 and we're going to do 2.8. Okay. All right, so for 2.8, it's telling you draw the mass spectra of oxygen if there are these 4 naturally occurring isotopes. Okay, so you're going to draw the mass spectra. So we're going to draw our x and y axis. We're going to label them, so we can just write percentage right here, and then here we can write the mass number. Bless you. Okay, and for our graph, our chart, we only need to just put the information that we have. Okay, so let's start with the x-axis, the mass numbers that we're looking at are 15, 16, 17, and 18. You guys don't need to do 0 through 18, just put the information that's there for you. All right, now let's do the y-axis. So let's start with the biggest one just so that we can have a frame of reference for it. So let's start with the 50%. Let's make that the highest one, 50%. Let's just label it 50%. Okay, and that's going to be occupied by oxygen 16. So we draw our bar going to 50%. All right, now the key thing I want to mention is that when you're drawing these mass spectra for the AP test, you don't need to make it like a perfect graph. You don't need to do 10, 20, 30, 40, and then try to scale it in between. You can even make it simpler than that. Okay, it just needs to be about the approximate height. Okay, so for example, the next highest one will be 25. 25 is half of 50, right? So for the next one, you can just put it around half and then write 25%. And just make sure that oxygen 17 goes to 25. Okay. Oxygen 18 is 20, so just under 25 somewhere, and just label it 20. And then just make sure that 18 is shorter than the 17. And then 5 is going to be the shortest, so just make a small line, 5%, and then just like that. So very simple, okay? The point that I'm trying to make is don't get so detail-oriented that you're trying to make every one of these things perfect. As long as you can communicate the information that you know, that 50 is bigger than 25 and whatnot, you should be fine. Okay? Just make sure you label things. We're going to talk about how to interpret molecule formulas just real quick. We're just going to kind of speed through it. So let's do 2.9 together, and then I'll have you guys do 10 and 11, the harder ones on your own. So 2.9, when you have a molecule formula like this might be hard to see. K3PO4. Just remember the number behind the element tells you how many of each element there is in that molecule. So how many potassiums are in this molecule? 3. So there's 3 potassiums. How many phosphorus? 1. And how many oxygens? 4. Perfect. That's it. Okay. So K3PO4, just remember the number behind it tells you how many of that element there is. So K3PO4 is made out of 3 potassiums, 1 phosphorus, and 4 oxygen. If there's no number, it means that it's 1. So light. We'll be balancing. All right. Let's see if you guys can do 10 and 11. Some of this you'll have to, hopefully you guys remember from your previous classes. I'll write it a little bit bigger so that you can see it, but it should be on your Chromebook as well if you guys want to zoom in. But we have NH4, 2, SO4. We have K3, Fe, C2O43. Okay, let's see if you guys remember how to interpret these molecule formulas. Okay, so again, if you guys ever get confused by the parentheses, just multiply the inside. There's 1 nitrogen, 2 on the outside, so 1 times 2, so 2. And then 4 times 2 is 8 hydrogens. Okay. Just so you know, your test questions will not be this easy, and the AP Chem test will not be this easy as well. This is kind of just stuff you're expected to know. Okay, I apologize. Okay, so before we move on to the last topic, which is ions, we're going to talk real quick about something we're going to talk about a little more in future units, but I want you guys to be aware of them. There are different types of formulas for molecules, okay? And you guys don't need to write the definitions down, but I want you guys just to be aware of them. The first is what we are used to, the molecular formula. And the molecular formula, what it tells you is the actual number of atoms in a molecule. Okay, so it tells you exactly how many of each element there is inside that molecule. So for example, if we have hydrogen peroxide, H2O2, there are 2 hydrogens and 2 oxygens. Okay, that's a molecular formula. Now, there's a different type of formula, which is called an empirical formula, and this gives you the relative number. Another way of thinking about it is it tells you the ratio between the elements inside that molecule. Some of you may have learned this, may not have, depending on your chem teacher, but we're going to talk about this a little bit more later. But Empirical formulas, they tell you the ratio of elements to one another. So going back to hydrogen peroxide, there are 2 hydrogens, 2 oxygens, but the ratio is 1 to 1, right? So the empirical formula will just be HO. Okay. Another example would be this right here. We got glucose, C6H12O6. There are 6 carbons, 12 hydrogens, 6 oxygens, but the ratio is 1 to 2 to 1. So it's CH2O. Okay, so just keep that in mind. Empirical formulas are ratios. Molecular formulas give you the actual number. Okay. Now, the question a lot of people ask is, why do we use empirical formulas then? Okay, and the reason why we use empirical formulas is when you're trying to find the formula of an unknown compound. Okay, so only when you know just the ratios or the weights of the elements, and we'll talk about this more later, that's when we use an empirical formula. And we can use the empirical to find the molecular formula. So it's a technique that we use, okay? And we'll talk more about this in, I think, next unit, maybe the unit after, but it's coming up soon. But I just wanted you guys to know the difference between these 2 types of formulas, okay? Okay, let's move on to the last topic now. We're going to move on to ions, okay? So ions. So we talked a little bit about ions earlier, talking about charges, but ions are basically when an atom has an unequal number of protons and electrons, okay? And basically they're elements that have a charge. You guys are probably familiar with these, right? An example would be O2 minus, H plus, Al3 plus, so on and so forth. Okay, it's basically if you have something on the top right, it tells you that there's an unequal number of protons and electrons. All right, so let's talk about how to find the charge. The charge is very easy to calculate. So the formula for charge is just going to be protons minus electrons. Okay, so that's why you can have a negative number. If you have more electrons, then you get a negative charge. If you have more protons, you get a positive charge. Okay, so let's do a little bit of, I guess, just checking up. So let's take a look at oxygen, O2 minus. Okay, I want you to go to your periodic table, and I want you guys to calculate how many protons and how many electrons does O2 minus have. Just write it down on your paper. Okay, so oxygen should have 8 protons, right? The number on top of the box is 8. Now, if the charge is -2, how many electrons does it have? 10, great. It's just 2 more electrons than protons. Okay, hydrogen has 1 proton. So if it's H plus, how many electrons does it have? 0, correct. You can have 0 electrons. And then last one, Al, has 13 protons. If it is +3, how many electrons? 10, great. Everybody good with finding electrons with protons? Great. All right, now before we move on, just some terminology that you should get used to. So an ion that has a positive charge, so if it's an element with a positive charge, we call that a cation. Okay? And then if it has a negative charge, it's called an anion. Okay? So I'm going to be using those terms just kind of naturally as we go throughout the year. We talk a lot about ions. Just keep that in mind. Those need to remember it. Cation is positive, anion is negative. Easy way to remember it is if you like cats, cats are positive. And Anne is the name of the girl that rejected me in kindergarten. So Anne is bad. Okay, Anne is negative. We don't like Anne. So cation is positive, anion is negative. Boo Anne. All right, so that is how you can determine cation, anion, and the protons and electrons. Let's move on. So I want you guys to go to your periodic tables, and we're going to make a quick note on it before we move on. Different elements, they want to become a certain ion a lot of the times. And this is called a most... So don't write this part right here, but don't write this. But there's something called a most common ion, and these are going to be the ions that an element wants to become. Okay, so they have a tendency to become these ions. Now the part I do want you to write, I'll do that in blue, is the first column, everybody wants to be positive 1, exactly. Second column, 2. Now this middle section right here, these are called the transition metals. They don't really have a pattern that they follow, so they don't have a most common ion. This third column right here is +3. This column right here is -4, -3, -2, -1, and these guys have no most common ion. These guys don't want to be ions at all. Okay, now you will be expected to memorize this. Okay, so +1, +2, 3, -4, -3, -2, -1, no MCI. Okay, yes. Okay, let us move on. So, we'll skip 2.12 because that's pretty easy. Okay, now we're gonna go on to ion, or when they become molecule. Okay, there are two different types of compounds or molecules that we're gonna be looking at. The first is called an ionic compound, and ionic compounds, they're usually formed from a metal and non-metal. But basically, they're going to be when you have a cation and an anion coming together. Okay, so that's kind of the easy definition. It's when you have a cation plus an anion. Okay, the second type is called a covalent compound. And we'll talk about this a little bit more later. But the key difference between ionic and covalent is ionic is when electrons are transferred. So electrons move from one ion to the other, and that combines them. And the other one is when electrons are shared. Covalent is when they're shared. And we'll talk more about covalent later. But for this unit, we're going to focus mostly on ionic. Okay, so the term that you'll usually see is covalent, but just a heads up, depending on which textbook you're looking at, or depending how old the person is that you're talking about chemistry with, some people do call these molecular compounds. So just keep that in mind. They mean the same thing. It's when it's a non-metal, electrons are shared, but some of the older folks tend to call them molecular compounds. Okay. So if you ever see something in your textbook or a video where that's helping you study and they say molecular, it just means covalent. Okay. Okay, but let's take a look at Na. So I want you guys to look at your periodic table, and on your paper, I want you guys to write down Na and also its charge. What's its most common ion? So write down the most common ion for Na. Just on your paper, write that down. And then also do that for Cl, for chlorine. So write down next to each other the most common ion for Na and the most common ion for Cl. If we take a look at Na on the periodic table, Na, what's its most common ion?
1.
Yeah, +1, right? It's in the +1 column, so Na is going to be +1. And chlorine, what's going to be its most common ion? -1, exactly. So we're going to have Na +1 and Cl -1. Okay, so on your paper, you should have written Na and then a plus sign on the top right, and Cl is minus. All right, now, if you take a look, it's positive and negative, right? And so what happens is one's a cation, one's an anion. They want to balance out their charges, and so they're going to get super duper close together. They're going to attract, they're going to combine, and they're going to get married and turn into NaCl. Okay, so that's basically the general idea of how ionic compounds form. You got a cation, anion, they're attracted to one another, and they form an ionic compound. Alrighty, guys. So let's go over those first four, and then I'll talk about the last two in a second. Again, the key for ionic and covalent is figuring out if it's metal and non-metal versus non-metal and non-metal. And like I mentioned last time, you're expected to do the reading before you come to class. And everyone did the reading for Unit 1, right?
I did.
And Unit 2, right?
No.
Of course, everybody did. It's okay. So if you take a look at nitrogen, anyone remember if it's a metal or non-metal? Yeah, this is a non-metal and another non-metal. Exactly. If you guys didn't do the reading yet, easy way to think about it is the left side of the periodic table are metals, the right side are non-metals. Okay, that's the easiest distinction. So pretty much, I guess the left and the middle, but this whole section right here is usually going to be metals, and then you got non-metals on the right side. So just keep that in mind, okay? But you'll see that in your reading. So since both of them are non-metals, this one is going to be covalent, okay? Because both are non-metals. All right, let's go to 213. We got Na2NO. If you take a look at Na, is it a metal or non-metal? This is a metal, and O is
Non-metal.
non-metal. Good. So this one is going to be ionic. Good. Okay, let's go to the third one. Calcium is a metal.
And non-metal.
Exactly, non-metal. So this one is also going to be ionic. And then the last one, exactly. So the last one is going to be covalent. All right, so that's how you distinguish between them. All right, so for the last two, the reason I wanted to do these with you is because these are going to be a little bit different, okay? Now, if you take a look right here, we got Mg3 and then parentheses PO4 parentheses 2. Okay, so these are a little bit different because now we have more than two different types of elements, right? Okay, if you take a look at Mg, what type of element is it? Metal or non-metal? Metal. Okay. Now, PO4, if you take a look, both are non-metals, right? And so the question becomes, is it going to be ionic or covalent? PO4 actually is something a little bit different. This is actually something called a polyatomic ion. Okay, so polyatomic ion. You might want to write this down on your paper somewhere, but this is called a polyatomic ion. Okay, and a polyatomic ion is basically a group of elements that still have a plus or minus charge. Okay, so PO4, even though it's made out of P and 4 oxygens, they like to have a -3 charge when they combine together. Okay, that's what a polyatomic ion is. It's basically a molecule that likes to have a charge. Just like how elements can have a charge, molecules can also have a charge. So PO4 is something called a polyatomic ion. So with this information now, if you guys take a look at our definitions, an ionic compound, we said it's usually a metal and non-metal, but they can also involve polyatomic ions, right? So this right here is going to be an ionic compound. Because it's a metal and polyatomic, and the definition tells us you can have a polyatomic in ionic. Yeah. Yeah, of course. Yeah.
Are the polyatomics always in parentheses or is it in the middle?
Just when you have multiple of them. So here we have two PO4s. So that's why there's parentheses. All right, and then it kind of leads into the next one. The next one right here is NH4Cl. NH4 is also a polyatomic. Okay, and so this right here is also going to be ionic. Okay, and we'll talk more about polyatomics in just a second. But just keep that in mind. If you have something that involves a polyatomic, you will require it's going to be an ionic compound. Yeah, what's up? That was okay for sure. Now, I do have some bad news. Is you guys do need to memorize the polyatomic ions that are important for this class. Okay, I know it's very unfortunate. You're going to need to know the name, the charge, and the formula. Okay, there are a handful that you need to memorize, or they're not going to ever quiz you. They're not going to be like, what is the name of PO43 minus? But they'll say they'll have a formula with like PO4, and you'll be required to know the charge, or in the name you'll have to know it. So let's actually scroll down a little. We're going to skip 2.14 and all of this, and I'm going to go to this chart right here. So I want you guys to scroll down to page 8 of the workbook. And you guys see this big table right here, right? Yeah. You guys have to memorize all of it. I'm just kidding. I'm kidding. No, I'm not for real. You don't need to memorize all of them. The ones that show up the most on the, I know you guys got a heart attack just now, huh? So the ones that you guys have to know, or will be expected to know for the AP test, are the ones with the red stars. Okay, so good amount, but still not too many. Okay, so right here, ammonium NH4 plus, nitrate NO3 minus, hydroxide OH minus, so on and so forth. The ones on the red stars are the ones that pretty much cover like 99% of the ions, the polyatomic ions that'll show up on the AP test. If you know these, you should be fine with all the polyatomics. Okay, so just keep that in mind. You have to know the ones with the red stars on them. Okay, so I'm not going to be, again, asking you guys, hey, what is the name of NO3 minus? You're just kind of going to be expected to know that it's nitrate and so on. Okay, so with that being said, with that bad news out of the way, let's do some more problems. So 2.14, what we're going to do is we're going to figure out what the molecule is when you combine the ions that we have for these samples. So I'll do A with you guys, and then I'll have you guys try the rest on your own. Okay, so we got Al3 plus, and we have Cl minus. Okay, and basically what we're going to be doing is we're going to be combining them, and we're going to figure out what molecule is going to be made. Okay, easiest way to do this is try to balance out the positive and negative charge. If you guys take a look at this, do we have more positive energy or negative energy?
We have more positive.
More positive energy, right? So we got to bring that aluminum, we got to make it sad by adding more chlorines, which is negative. So how many chlorines do we need in total to balance out the aluminum?
We need 3.
We need 3, right? Because that'll give us 3 minus. And so you need 1 aluminum, 3 chlorines, and so the molecule that you make is going to be AlCl3. So what we're trying to do is we're trying to balance the positive and negative charge. Alrighty guys, let's go over the answers for B, C, and D. I'm just going to kind of speed run through them, but if you have any questions on a specific one, please let me know. I'll go a little bit more detail. So if you take a look at B, you got Al3 plus and O2 minus. The way to balance that out is you need 2 aluminums and you need 3 oxygens. And so your formula should be Al2O3. Okay, everybody good with that? Okay. For C, I had you guys look up the most common ions. Mg should have been +2, and then P should have been 3 minus. So you're going to need 2 phosphorus and 3 Mg, kind of the opposite of B. And so you're going to have a formula of Mg3P2. All right, now for the last one, we have a polyatomic, which changes things a little bit, but hopefully you remember the formulas from earlier. Mg is still +2. If you take a look at nitrate, it's -1. So you're going to need 2 nitrates to balance out the 1 Mg. And so you're going to have to put them next to each other, Mg and NO3, but you need 2 of these. So what we're going to do is we're going to put that in parentheses and put a 2 behind it. Okay, and that's going to be how you write that out. All right, any questions on any of those specifically? Okay, that's how you write, or that's how you figure out what ionic compound is formed by these ions. Alrighty, if there's no questions, let's go on to the last part of the unit. Congratulations, guys. This is our first unit that we're finishing today. I know, great job. All right, last part is, I think, the most boring part. It's naming. Okay, so we're gonna. I know. Oh, see, your groans give me strength. I told you, I want you guys to come in here sad and leave sadder. Okay, so the way that you write the name of the ionic compounds, there's a couple of rules, but they all kind of build on each other, so it's not that bad. Okay, so let's take a look at our first example, because I think examples are the easiest way to learn this. So we have KCl. If you take a look at KCl, it's made out of K, and the name of K is potassium. Okay, the second element is Cl, which is chlorine, right? But when you name an ionic compound, you change the ending of the anion to IDE. So it goes from chlorine to chloride. Okay, and that's how you write a basic ionic compound name. You put the cation first, so in this case potassium, and then you put the anion behind it, and you just change the ending to IDE. Okay, so see if you guys can take a minute and do 2.15 CaBr2. Oh, also, the number doesn't matter. Okay, so don't worry about the number. Okay, so see if you can take a minute and do CaBr2. Write the name of CaBr2. All right, guys. So calcium bromide. Pretty good with that?
Yeah.
Cool.
Yeah.
Ca is calcium. Br is bromine, but we changed the ending to IDE. Now, some of the endings, the IDE endings they're a little bit different. So I want to go over them with you guys so that you guys have them available. That way you're not guessing. You don't really need to memorize this, and if you make a small mistake, I really won't care. But nitrogen turns into nitride. Oxygen turns into oxide. Fluorine turns into fluoride. Sulfur turns into sulfide. And then chloride, obviously. We got bromide. And usually those are the ones that you'll see for this class. Again, if you make a mistake and you write like oxide, I'm not going to mark you wrong because you know that it's IDE. But just so that the AP graders don't laugh at you on the AP test by making that mistake. These are the 6 most common ones you'll see. Oh, and then, sorry, one last one, iodide. All right, so those are the endings. And this first rule is when a metal forms only one type of cation. So basically, if it has a most common ion. But if you guys remember, we talked about how the ones in the middle, they don't have a most common ion, right? So for example, iron, Fe, it's in the middle of the periodic table. Fe can form multiple ions. So you can have 2+, 3+, 4+, so on and so forth. So if a metal is in the middle of the periodic table, if it can form more than one type of cation, then there's a different rule that applies, okay? So let's say, for example, we have, let's do this. Okay, so on your paper, I want you guys to write Fe, and then we'll write Cl3. Okay, so write this on your paper. This will be our example. FeCl3. Okay, so we always want to start by figuring out the ion that we know the most common ion of. So chlorine has a most common ion, right? What's chlorine's most common ion? -1, right? So chlorine is -1, and there are 3 of them, right? So there are 3 chlorines, Cl minuses. And if you take a look, we have 1 Fe, right? So what does Fe have to be in order to balance out these 3 chlorines? 3. So that means in this situation, Fe is 3+. Okay, so if we're going to write the name of this compound, what we're going to do is we're still going to write the name of Fe, which is iron. So we're going to write iron. But since iron can form multiple ions, we need to specify what type of iron it is. So it's iron +3. So what we do is we write parentheses, and in the parentheses we do 3 in Roman numerals. So iron 3. And then the ending is still the same. It's chlorine, so we write chloride. Okay, so that's kind of the variation. If you have a metal that's in the middle of the periodic table, we have to do the parentheses. All right, guys, so let's go over this, and then we got one last rule before we end class. Cu is copper, and if you guys notice, copper is in the middle of the periodic table, right? So we got to write the parentheses for this one. So we need to figure out what the charge is. Now, we got Cl, again, we know that it's -1, right? So if we got 2 Cls, what does copper need to be in this situation? +2. Yeah, because you got to balance out the -2. I got you, though. Okay, so copper is going to be +2, so we got to write copper 2, and then chlorine changes to chloride. So this chemical is copper 2 chloride. All right, for B, it's kind of a variation of it, but in this situation, the difference is the chlorines. How many chlorines do we have here?
We have 1.
We have 1, so Cl minus. So what does Cu have to be to balance out this chlorine? 1 plus 1. So here, we're going to have copper, but 1 chloride. Okay, so that's kind of the difference here. If you got a metal in the middle, it's not going to have a most common ion, so we need to calculate what the charge is. All right, any questions on that one? All right, last thing before we go, I know, we're going till the end. Oh, one quick thing. Sometimes you'll see a different name. This is what the old people use. We don't really use this terminology anymore, but you might see this in like a textbook or a practice problem, so just want to give you a heads up. You don't need to memorize these, but if you see terms like this, chromis, chromic, cobaltous, just Google what the conversion is to the ones that we use now. Okay, just want to give you a heads up.
Why do we put cobaltous on the shelf? That's nuts.
Anyway, yeah.
Why is it always linked with a ion instead of like let's say bromine on the periodic table?
Yeah, we change it to "ide" when it's in an ionic compound. Yeah. All right, so the next rule that we need to know is when we have polyatomic ions make things really easy. If you have a polyatomic in the ionic compound, just write the name of the polyatomic ion. So let's do this one right here really quickly. So we see a polyatomic SO4. If you look on the polyatomic chart, the name of SO4 is sulfate. So we just write sulfate. You don't change it to anything. You don't add parentheses. You just write whatever the name is. And that's why you need to memorize it for the AP test, because you need to know what the name is. So this is sulfate. This is still iron, but if you remember, iron's in the middle of the periodic table. So this one is going to require parentheses. I'll just do this one for you. Sulfate is -2. There's one iron balancing that out, so this is +2. So this would be iron 2 sulfate. Okay, and then the last one is going to be this. I want you guys to try this one on your own. They're both polyatomics, so see if you can find it on the table. And again, if you have a polyatomic, don't change anything about it. You just write the name. So take about a minute. See if you guys can do 2.7. All right, guys, it's ammonium nitrate. NH4 is ammonium, NO3 is nitrate.